Okay, so the first thing I'd like you to do is take that thing and point it at the fluorescent lights. You should see off to the side a little rainbow.
Yeah.
Yeah, is that rainbow continuous? Does it have gaps in it, or is it perfectly? Yeah, it's gappy. So actually fluorescent lights are not actually a continuous spectrum. I don't know if I've got one that doesn't have slits on it. It's pretty. Now what I want you to do is point it outside. I'll turn this off. Point it outside and look at the look at the incandescent light from the sun. The incandescent means hot, and this is black body, and this stuff should be pretty continuous. Yes? Yeah, there we go. Right. Now look at the light from the projector. Shine it up at the screen and see is that continuous? Not entirely, and that's because it's filtered through an LCD, which may take some things out of it. Okay, so this is sort of an interesting thing. Okay, but this is definitely an incandescent light. It's got a very hot piece of metal that's tungsten that's radiating this energy like that. Right. So this was an amazing thing. Atoms and different elements had different elements had spectral lines. They had particular colors that they would send off, and I'm going to show you these particular colors here in a moment. And you could tell hydrogen from helium. And these colors were both light emitted from the element, and they were also light that was absorbed by the element. The same lines that an element could emit, it also apparently absorbed when it was in the atmosphere of the sun and was therefore filtering the light from the hot surface of the sun. Right? Now, spectra that were due to emission were called emission spectra. And spectra that were dark line spectra that were due to the atmosphere absorbing these lines were called absorption spectra. You guys are so smart. Okay? So there are these two different spectra. There are emission and absorption. And all elements absorb and emit the same lines, yet we had no clue at the time why these things emit and absorb these particular lines. And if you're going to make a theory for atoms, your theory better predict these lines, because that's sort of the most exciting thing going on. Right? So let's look at some of these spectral lines, and I will be careful not to put my fingers in the sockets. Okay. So the first thing I'm going to do, I know, there we go. Okay, the first thing I'm going to do is I'm going to put a neon bulb in there, and if it's not red, then yours is going to work with this. You'll be able to see these. If it's not red, it's not neon, because that's neon, and neon is red. But any sign with, for example, mercury or oxygen or whatever they put in these signs to make them different colors is called a neon sign, because neon was the first one, and it's a really bright predominant color. Yeah? So a neon sign actually has neon in it, right? And then just a word of caution. Those glowing signs that are actually like this. By the way, nowadays they've got them. They can make them with like LEDs and stuff like that, and they're not actually 10,000 volt transformers zapping the crap out of the electrons of the atoms, right? Okay. But anyway, those signs, if they are actual neon signs, they have a 10,000 volt transformer attached to them. That's that big box that's attached to the signs that you see in store windows. Okay, that is a 10,000 volt transformer. Don't let your 4-year-old sit there and play with it with their moist little hands. Yeah? I see parents and they're like, I am letting my child play with this 10,000 volt transformer. Not such a good idea. Maybe. Just maybe a little safety guideline there. For sure they've got them insulated pretty well, but maybe they're not safe, right? So anyway, what do you see? If you point the thing at that, do you see the bright lines off to the side?
Yeah.
Are we seeing that? Yeah, there we go. Put the slit vertically so that you can see the whole thing through there. And look off to the side, and you ought to see a series of bright lines.
You can only see up to green.
Yeah. There we go. Are we seeing the bright lines? Yeah, that's kind of cool. Switch ones with somebody. Get somebody else's, Mary. Don't turn the thing.
Radio waves, microwaves,
Infrared light, ultraviolet X-ray, fight, fight, fight. Gamma rays.
Woo! Now we're talking.
This class is so much fun.
Okay, now I'm going to turn off the thing. Let me just put in, not because it's pretty, But because Bohr actually solved this one, okay, I'm going to put in hydrogen. There we go. Hydrogen is pretty. It's got like a dark blue and a dark green. Yeah?
I heard we're gonna
Yeah.
run cars off this once we get cars that are bigger than
Hydrogen, yeah. Where are you going to get your hydrogen? Like, anyway,
tanks would have to be bigger than the cars.
anyway,
I'll throw a tank, you
this is hydrogen. Do you notice that this has different spectral lines? Yeah. You also know, by the way, that it looks a different color, right? It looks kind of a purpley whitish color, whereas the other one looked like kind of like a bright red. Okay, so let's try another nutter butter. The first one was neon. This is hydrogen. Now I'm going to put mercury in there. This is a mercury vapor light. We've heard of these, yes? What color should this be?
Yellow, because that's what it's
Yellowish, whitish, sort of. It looks different. I don't know why, but it's basically a color of white. There we go. Maybe it's because they excited at different energies, right? So what's going on here, and we now know that this is what's going on, but Bohr didn't know this going into it, is that basically this is 10,000 volts alternating current. The electric field is taking electrons and moving them up to a high energy level, and they are going down, and when they go down, they emit light. Yes? The spectral lines that you see correspond to what? The energy levels, they have something to do with the energy levels that the atom has, and there are only certain energy levels available. Are there a lot of them for this guy? Or is it just kind of a smear of lines, like a forest of lines? Yeah, there we go. Is that possibly because Mercury's got a buttload of electrons? Yeah, it's a heavy element. It's got just a buttload of lines, and so... Yeah, but there's a smear in there, isn't there? If you had a good... Just blue and green. There's not a forest. Not so much. Yeah.
There's kind of an oranges.
Yeah. The second thing you need to know is that you guys have a diffraction grating that is not so good. I mean, believe it or not, the thing you're holding in your hand isn't actually the state of the art. You can spend $40,000 and get a mediocre diffraction grating. You spend much, much more to get a good one. The piece of plastic that you have was actually just pressed against a great diffraction grating, a very nice one, which makes it, by the way, a piece of plastic that was pressed against a very good diffraction grating, right? But it'll act sort of like a diffraction grating. Basically, you need to make a whole bunch of little scratches in something. They all need to be the same spacing. They all need to be parallel, and that's very expensive to do that, okay? So that's why, yeah, we're not getting great stuff. So let's just put one more. I'm going to put, put them all in at once. I'm going to put in oxygen just for fun, because love is like oxygen. Sorry. That was not so good, is it?
Now put a new one in.
Here. Hold on. That better? That's not very good at all. No. I'll put a different one in. I think oxygen is like overrated. Yeah, maybe. Here we go. Carbon dioxide. Let's see if carbon dioxide is. Here's an interesting thing, though. These spectral lines are like fingerprints for the elements, yes? Okay, so if we had seen oxygen spectral lines, we'd know that there was oxygen in that tube. A spectroscopist could look at that. A spectroscopist can actually look at the atmosphere of a distant planet when the star's light shines through that planet, and they'll be able to tell us in the near future whether there's oxygen on that planet. And the only reason for oxygen in the atmosphere of a planet is that there's life on that planet. So this is sort of an interesting thing. And then the second little bit of trivia that I will give you is that helium, helios means what? A heliostat tracks the sun, right? So helios means sun. Helium means literally sun element. It was discovered by its spectral lines in the spectral lines of the sun. Can we not do that right now while I'm talking? Can you just have a seat? Thanks. Okay. So helium was discovered in the spectral lines of the sun